Alrighty, we are back again with a little bit of geometry. We are in Chapter 9, Section 6, and we're looking at solving right triangles. Alright, in the previous lesson, we found that in a special right triangle, cosine of 60 degrees we found was a half. Well, if we didn't know the cosine, if we say this is cosine of angle A, and that is 1/2, well, we know that cosine of 60 degrees is 1/2, so then we could say that A must be 60 degrees, right? Well, if I don't know that, there's a way to find that. I'd have to divide by cosine here, and instead of writing 1/2 divided by cosine, I'd do A, or the measure of angle A, is, and divided by cosine is to the negative first, right? So that's the inverse cosine 1/2. Okay, so inverse cosine of 1/2, if I type that in the calculator, that's your second button. Second cosine gives you the inverse 1/2, and that would give you 60 degrees. So these are the inverse trigonometric ratios. Okay, the inverse tangent is TOA, opposite to adjacent, right? Remember SOHCAHTOA. SOHCAHTOA. So the opposite side would be A to the adjacent side B, and that would give me the measure of angle A. Or, if I know the hypotenuse, then I'm going to use either sine or cosine. If I know the hypotenuse and the adjacent, I'll use cosine. If I know the hypotenuse and the opposite, I'll use sine. Alright, so let's solve this right triangle. Solving means find all sides and angles. So solving a right triangle, we're missing side C, and then we want to find these acute angles here. Okay, so we will start with finding C. In a right triangle, we use Pythagorean theorem. A squared plus B squared equals C squared. And A and B are 2 and 3, so 2 squared plus 3 squared equals C squared. That gives me 4 plus 9 equals C squared, so C is radical 13. Alright, I have C, radical 13, and now I want to find these two angles. So I know all the sides. I'm going to use 3 and 2 because those are more fun to work with, so I'm not going to use the hypotenuse, which means I'm going to use tangent. Okay, so we know that tangent B is opposite to adjacent, so opposite to adjacent, which would be 2/3. Well, if we want to find B, then we have to do the inverse tangent of 2/3, and that will give me the measure of angle B. So I'll type that into my calculator, and that gives me about 33.7 degrees right here. 33.7. And then knowing that this is 90, that leaves 90 for these two angles, so I can do 90 minus 33.7, and that'll give me my third angle of 56.3 degrees right here for A. And now I have solved that right triangle. Alright, here's another one. In this case, I know one angle and I know the hypotenuse. Okay, so if I know the hypotenuse, I could either use sine or cosine. If I use sine, okay, sine of angle H, that would be sine SO opposite hypotenuse. So H over 13. And then I would multiply each side by 13. And H in this case is 25. So we'll put 25 there. Type that in. Sine 25 times 13 is 5.5. And that would be H. So found this, 5.5. Now that we know two sides, we could use Pythagorean theorem, but because we're having so much fun with this, we're going to use the cosine to find this, and that is cosine 25 is g to 13. Multiply by 13 again on each side, times 13, and that is about 11.8 that's what we get for g right here. So 11.8. And this third measure, I don't need to do a lot of calculating. I know that this is 90, so 90 minus 25. And that gives me a measure of 65 for this angle. There you go. Solving right triangles. Lots of fun. Check in again next time for another fun lesson.